This is Dan Schneider. On this Dan Schneider video interview, the subject is infinity, and I will be speaking with philosopher Graham Oppy about the subject. We'll be talking about its history, the philosophy of it, and its numerical import or mathematical import, and the conversation will begin in a moment. Graham Oppy is my guest. He is a philosopher who has written on the subject in infinity. And before we get into the meat of the subject, I do like to give my guests a few minutes to give a little bit about themselves. So Graham, welcome. And if you could tell me and the viewers a little bit about yourself and what you've written about the subject of infinity.
Okay, so I'm a philosopher based in Melbourne at Monash University. My main field of interest for the last 25 years has been philosophy of religion. So I've written lots of stuff on arguments about the existence of God. My interest in the topic of infinity is in part independent of my interest in philosophy of religion, but it's also related to it because questions about infinity come up in connection with various arguments about the existence of God, including cosmological arguments and teleological arguments and Pascal's wager and so on.
Well, when I spoke a couple of days ago with Adrian Moore, we did talk a little bit about sort of the religious aspects of infinity. So let me begin there with you on that. Do you think that the very concept of infinity, or the infinite, the boundless, is tied up in notions of the divine?
So I think that there are really two separable notions of infinity. So there's a lot of, in the Christian tradition, there's a lot of talk about the infinite, using that as a name for God. And that's connected to ideas about either God's sort of maximality, so God knows everything or God can do anything and so on, and that suggests certain kinds of infinite powers, or it's related to ideas about God's being outside of time, and then there are sort of questions about whether time's infinite or not, and so on. I think that the mathematical notion of infinity that's developed gradually over time is independent of that one, but applicable, so that contemporary understandings of the infinite usually do draw on mathematical ideas. That is, contemporary understandings of infinity, even as applied to God. So if you think that God's knowledge is infinite, it's quite likely that part of what you've got in mind is that there are infinitely many propositions that God knows, for example.
I had also spoken with Adrian about the idea that the concept of infinity may be a human desire to sort of corral that which is beyond understanding. Do you think that in a philosophical sense, just the idea of infinity as a concept is a way of dealing with that which we don't really deal with in a day-to-day basis?
So if you think about the history of the use of the term, of terms related to our term infinity, that's going to be partly right, but there are questions about infinity that come up in pretty everyday contexts, at least in relation to physics, for example. So if you think about how many stars there are, or whether space is infinitely divisible, whether there are smallest things, or whether no matter how small you go yet smaller, you've got notions of the infinite there. And there are many of our kind of ordinary concepts that, if you push on them, will lead to questions about infinity. So I don't think that it's just the kind of something mystical or something that's sort of pushing into areas that we feel are somehow beyond the reach of our science. Our science, modern science, uses the infinite everywhere.
There are, in modern parlance of infinity, different types of infinity. For example, the infinity of all whole numbers, the infinity of even numbers, the infinity of irrational numbers, and yet intuitively we would think, well, these have to be different in size because we know that only half of the numbers are even or odd. So how could the infinity of all even numbers be somehow equal to the infinity of all whole numbers. That's a purely mathematical idea of infinity, apart from what we were talking about, is it not?
Uh, that's true. And the worry about different sizes of infinities is an old one. And the point that you make, or the example that you're referring to there, that there are just as many natural numbers as there are even natural numbers in some sense, was one that bothered people at the dawn of modern science. So Galileo, for example, thought that there was something very suspicious about any talk of infinity, because he thought that there was a kind of contradiction here. On the one hand, there are more natural numbers than there are even natural numbers, but on the other hand, there's exactly the same size. So that sounds like it's a reductio of the idea that there could be an infinity, right? And lots of people have had that sort of attitude over time. But what you were really adverting to, I think, is that in the 19th century, set theorists, in particular Cantor, kind of brought an order to at least the mathematical investigation of infinity. And so once you introduce the notion of cardinality, which is one way of making precise what you mean about the size of a collection, then it just turns out that the cardinality of the natural numbers and the cardinality of the even natural numbers is the same. Whereas, to pick on something else you mentioned, the cardinality of the irrational numbers is greater. There are more irrational numbers than there are natural numbers.
Um, but that does bring into mind what we would call seeming paradoxes, if not actual paradoxes. Um, the different sizes of infinities, and of course, one of the earliest notions of the infinite is Zeno's paradox, where you have to travel half the distance, then a quarter of the distance, then an eighth, the 16th, the 32nd,
Yeah.
etc., to get to somewhere. And his idea is that motion, therefore, is impossible, and yet we move all the time. We can take a step and, uh, easily be motive beings. Do you think that infinity, more than any other mathematical concept, embraces or is spawned by paradox?
Is it spawned by paradox? There certainly have been lots of tricky paradoxes about infinities, both large and small. So I think of the Zeno paradoxes, the two that you mentioned, the one that suggests that you can't ever get going because to move to somewhere else, you'd have to get halfway first. And in order to get there, you'd have to get halfway and so on. So that was one kind of proof that motion was impossible. But there's also the Achilles and the tortoise. If the Achilles gives the tortoise a head start, Achilles can never catch up with it,
Yeah.
because the tortoise is always, by the time it gets to where the tortoise was, the tortoise has moved on a little bit more. Now, I think with those paradoxes, there's something wrong with the arguments, because as even Zeno himself recognized, motion is possible.
Yeah.
We do move around. And so the question is, what's wrong with the argument? And Zeno might have wanted to pin the problem on the infinite, but the idea that space and time are infinitely, that we're supposing that space and time are infinitely divisible for the purpose of both of those arguments. But there might be something else that we want to pick on, rather than the idea that we can make a coherent conception of infinitely divisible space and time.
I didn't get into my conversation with Adrian Moore too much about the paradoxes. Let me ask you, as someone who has studied this, what do you think is perhaps, I guess we might say, the most troubling or the most interesting or the most frustrating or vexing paradox related to the infinite? At least in your personal opinion.
There are lots of tricky paradoxes about the infinite. And
well, give me your top two, say.
Yeah, so I'll give you one in a minute. I just want to say that part of the challenge is to come up with a view that will deal with all of them. together.
Mm-hmm.
So it's not so much that there's one or two that are particularly hard. But let's consider, so this is a kind of paradox that the American philosopher Jose Benedetti specialized in developing. So he came up with a range of really interesting and fun paradoxes in the late 50s and early 60s. So here's one of them. We imagine that we've got an infinite number of gods, and there's a person who the first god determines, so the person's at a certain spot and they're going to head in a certain direction. And the first god determines that if they go a meter in that direction, when they get to the meter point, they will paralyze them so that they cannot move any further. And then the next god determines that if they get to half a meter, they'll paralyze them so they can't get any further. And there's another god that will paralyze them if they get to a quarter of a meter, and so on. So you've got these infinitely many gods. And the person's at a point. And the conclusion is that although none of the gods have to do anything, the person can't move, because were they to move anywhere, there's a god that would have paralyzed them before they got to that point. So you have this kind of infinite paralysis where all you've got is a whole lot of gods that have formed the intention to stop the person from moving. Now that's immensely puzzling, right? Because the person's at a point, it seems like there's nothing that actually intervenes to stop them from moving. There's just all these gods that have these conditional intentions. I'll paralyze you if you go a meter, or if you go half a meter, or whatever. And obviously, on the assumptions, the person can't move. How can that be? What kind of weird force is this that's produced by the mere unacted on intentions of all of these infinitely many gods? So the conclusion that some people want to draw from this is, okay, so there's something wrong with the notion of infinity. I think that there's something wrong with the setup. The idea that there could be infinitely many gods with these kinds of powers. But that doesn't mean just because you think that certain kinds of infinities are impossible that you think that all kinds of infinities are. I don't think that this puzzle shows that there's something wrong with the idea that space and time are infinitely divisible, for example.
Well, that, in a sense, that sounds like sort of the antipodes of the Zeno paradox. The difference being, though, with the Zeno paradox is that we're dealing with actual physical lengths, whereas in the example you just gave, that's almost more of an inner psychological paradox based upon the threat of infinite.
I'm not sure that it's psychological, because the gods have the power to paralyze this person.
Okay.
All of the gods, sorry, any of them, but the person has to. None of the gods have to act unless the person moves to a certain point, right? And so, if we're thinking about where the person is, there's nowhere they can go, because in order to get there, there's sort of infinitely many gods that would have paralyzed them and stopped them from getting to that point. But the point that they're sitting at, if they haven't moved, there's no god that's paralyzing them to make them stay at that point. So why can't the person move? The person can't move because if they were moving, there'd be infinitely many gods that would have already paralyzed them for any point that they get to. But there's no actual god that's stopping them from moving. There's no god that's exercising a paralyzing power. So that was the thought. The thought there is, it's not so much psychological. It's that there's this weird effect of a sort of nested set of intentions that stops somebody from doing something, and that just seems bizarre.
Yeah. You had earlier mentioned a paradox regarding tortoises, and that brings to mind the idea of tortoises on top of tortoises on top of tortoises on top of tortoises all the way down. And that gets into things like infinite regress and uncaused causes and whatnot. And naturally, since you and I exist, and we know at least some things exist, whether or not we're computer replications or we're the dream of a god, that would suggest that there is some base level reality. So even if we accept that at some level that maybe we're a dream of a god or a computer simulation, doesn't uh, we could go almost all the way down, but there has to be some base level reality. So, does the idea of the infinite somehow represent something beyond the material universe, say?
So it does seem as though the idea of the Earth resting on the back of a giant turtle, supported by another turtle, supported by another turtle, and it's just turtles all the way down. There does seem to be something hard to accept in that idea. I'm not sure whether that translates into it's being equally unacceptable to suppose that the past is infinite. So if the past is infinite, then for each time there's an earlier time, that's what it takes for the past to be infinite. It may well be that there are lots of things that you can describe, infinite scenarios, that really are impossible. So to give an example, maybe the turtles all the way down scenario would do, but nobody takes that kind of idea that the Earth rests on a giant tortoise very seriously. So let's go with a different one. The example that I think David Hilbert must have invented because it's called Hilbert's Hotel. So imagine a hotel on an infinite plane that's got infinitely many rooms in it. The hotel might be full, but someone arrives at the front desk. You move the person in room 1 to room 2, the person in room 2 to room 3, and so on. And you've accommodated an extra person in what was a full hotel. And that seems absurd, and yet it seems to be something that you could do if you could have an infinite hotel. Now, I'm inclined to think that there just couldn't be an infinite hotel. Obviously, we couldn't build one,
Yeah.
but there's nowhere in the universe where there could be one either. And I'm inclined to think that there couldn't have been, given that what the sort of range of universes that are possible. There's none in which there's an infinite hotel, but that doesn't mean that there couldn't be an infinite past or infinitely many stars. It's just that you can tell sort of absurd stories about anything, and some stories about infinities really are absurd. But the kind of interesting question is whether they all are.
Yeah, well, that gets to the idea of, say, we could posit that there might be an infinite number of subatomic particles in in the cosmos, even that which is unobservable. We could realistically perhaps argue that. We may be wrong, but we could argue that. But how could, let's say, if I said my love for my wife is infinite, how could I argue that? Because how do you measure that? At least subatomic particles are theoretically measurable.
Okay, so that sort of connects to some of the discussion about God, I think, because what would it be to be infinitely loving, for example, or infinitely good, and so on? It seems there that using the word infinite is relative to the mathematical use. It's kind of metaphorical. What you mean is that it's sort of unsurpassable. No one could have a greater measure of this than you've got, or something like that. It doesn't mean anything to do with Cantor and putting things into one-to-one correspondence with the natural numbers or the real numbers or whatever.
Okay, Graham, let me ask you another question here, and this is something that I also didn't get to speak of in my last conversation on the infinite. We now use what is called Arabic numerals in most mathematics. We also obviously use letters and things too, other symbols. But the West started out, at least Europe started out, I think, with mostly Roman numerals. I'm wondering, did the concept of the infinite exist in the Roman mindset? And if so, what was represented by it? We didn't have the lemniscate, which is the infinity symbol back then, did we?
So there's talk about, so this goes back to things you said right at the introduction. So there's talk about infinity in Aristotle, and this is before the rise to power of Rome. So this is in the heyday of Athens. And Aristotle definitely considers whether space and time might be infinite in the large and in the small. And indeed, Zeno is before Aristotle, and Aristotle discusses Zeno. So there are ideas about the infinite in something approaching the modern mathematical sense that before the Romans. So I think that the Romans do have, at least in a kind of, in some sense, they do have something that's approaching the modern conception of infinity. It's just not all that well worked out. Aristotle thought that there couldn't, nothing could be actually infinite. So there could be things that were growing without limit, but they could never actually, it couldn't be that at a particular time you had an actual infinity of things. So, for example, Aristotle would have, in answer to your question about the fundamental particles, would have said at any time there can, at most, there'll be some finite number of fundamental physical particles, even if that number, for whatever reason, is growing over time and perhaps growing without limit. That's, if it is growing without limit, then it's potentially infinite, but it's not actually infinite, according to Aristotle.
In the real world, do you think that perhaps the only thing that possibly could be infinite is time? I mean, do we really believe that there could actually be physical infinity, i.e. an infinite number of planets, an infinite number of subatomic particles, as I mentioned, an infinite number of stars, an infinite number of living beings or creatures? Or is maybe time perhaps the only infinite thing that is possible, do you think?
So when cosmologists often are only interested in the observable universe because it's a bit hard to learn very much about the universe that we can't observe. The observable universe is definitely finite in the large, right? It has there's a number of particles. I think the estimate is about 10 to the 80 atoms, something like that. But anyway, there's a definite number of atoms that in the observable universe. There's a question about going to the small, whether there's a level at which you hit temporal and spatial atoms, so whether there's a kind of a smallest length and a smallest time interval. So even in the observable universe, you might get infinity going to the small, but you don't get it to the large. Some people do speculate about the universe beyond the observable universe. I mean, there are a couple of kinds of speculation. One kind is just about the universe that we can't see, but the other kind is about other universes. Maybe we're part of a multiverse. And people who think that there's an infinite past, who think that there might be an infinite past, tend to think that there's a multiverse and that the multiverse is in a kind of space that has there's a kind of time for it, and that's the time that goes back infinitely. It's not that the sort of time of our universe goes back infinitely. Most people suppose that time begins with an initial singularity, or maybe that's not exactly right, but something just prior to the inflation from which our universe emerged.
Yeah, I had brought up in my earlier conversation on infinity, but I've also in some other shows when I talked with philosophers that I think infinity, in a sense, and perhaps realistically, is almost the opposite of the concept of zero or nothing. And I mean it in this sense, in that human beings tend to have an awful lot amount of trouble visualizing or contemplating very large things. When we think of nothingness, what is it? Is it blackness? No, it can't, because that's blackness. It's not silence. No. And the closest I've come to thinking of that is, what was I thinking, say, 150 years ago? Well, I wasn't thinking anything. That was over a century before I was born. But when I think of the infinite, to me, that seems almost at the other antipodes of thinking of nothing. I mean, how in my mind could I conceive of all things that ever were at all times, all possible physical things, all possible events, all possible beings, all possible ideas, etc.? To me, if I think of the infinity of possible things that could have ever been, it's something that's just overwhelming. So do you think that infinity, in a sense, is just sort of this catch-all term that we use the way we think of a term like nothing for these things that are just beyond the human ability to conceive?
So that will be true about some uses of the word infinity. And again, I think that some of the kind of theological uses of the term infinite are like that. So we have this idea that God's, or some people do this idea that God's kind of beyond our ability to conceive, in much the same way that you're thinking that the possibilities for the actual world are really beyond our capacity to conceive. And so sometimes when people are talking about God's infinity, it's really that's what they've got in mind. But if you look at the mathematics and you look at what Cantor does, it seems that set theory provides you with a way of making at least mathematical infinity tractable, right? You can talk about very large infinite sets in a way that seems to make perfect sense. Whether any of that's got any application to the actual world or the space of possibilities is a further question.
Since you've mentioned him 2 or 3 times, can you just tell people who may not be familiar who Georg Cantor was and what his major contribution to the idea of infinity was?
So Cantor's a mathematician from the 19th century. He's the founder of what's now called Cantorian set theory, the theory of sets. In particular, he was interested in infinite sets. He was the person who produced a series of proofs of results that are now standard. He began with by showing that there are just as many rational numbers of the form P over Q, where P and Q are both natural numbers, as there are natural numbers. And then he showed that there are more real numbers than there are natural numbers. And then he proved a whole lot of other interesting results as well. It's a pretty common view, at least amongst mathematicians, that Cantor basically got these things right. There were some questions about set theory that he didn't resolve that were subsequently developed. And there are, so for example, mathematicians these days tend to just suppose that what's called the axiom of choice is something that you should accept. And that's related to an idea about infinity. And yet it turns out that there's a sort of choice for mathematicians. They could go with the axiom of choice and they might not. You could develop mathematics either way. It's just more interesting if you develop it using the axiom of choice. So that's a little bit about Cantor and some of his importance.
Since we have talked about what I guess we could call the mathematical idea of infinity and sort of the diurnal, the sort of everyday idea of infinity, why is the same term actually used, since they do seem to refer to different things? I mean, related, but different things. Why is such a term used if it confuses more than maybe it clarifies?
Maybe that's just because of the weight of history. So the problem is that there's no one who gets to legislate about linguistic usage. And it's very well established that people use the word or the expression infinite in a range of different ways. It sort of doesn't really matter that that's the case, so long as in a particular context, you're very clear about how you're using the word infinite. So philosophers will be quite careful to say, when I'm talking about infinity, this is what I'm focusing on. I'm focusing on this mathematical idea, or I'm focusing on this way of talking about God, or whatever it is.
With the idea of the infinite, it brings to my mind the idea that mathematics, as generally perceived, I've always thought is just another type of human language, the same way that the written word, verbal language, or written language is, and also the way that musical notation is. We use symbols to express these abstract concepts. I've sometimes heard of people thinking that in this multiverse that you mentioned, that there could be a pure mathematical universe, and I think, what the hell is that supposed to mean? What could that possibly mean? So do you think that the idea of the infinite may be a limitation to human mathematics, and that in a cosmic sense there could be sentient beings that maybe have a better sensual feel of the universe, and therefore the idea of infinity might seem absurd, just theoretically?
Okay, so there's a bit packed into that question. It might turn out that the universe is digital and so finite, right? That it's made up, it's got a finite number of bits, and there's a finite number of stages. And Aristotle was perhaps right that it'll go on and on and on, but there'll be no point at which the whole of history will be infinite. At any point that you pick, there'll just be a finite amount of stuff. So I think that, and perhaps though this is a bit harder, maybe there's occasionally some chance involved in the evolution of the state of the universe, but the number of chances is always finite as well. So there's only finitely many different ways that things could go. So if we consider a certain number of stages of evolution of the universe, there's only a finite range of possibilities as well. It's quite big, but it's still finite. And so I'm pretending that it's digital, after n steps, there might be 2 to the 2 to the n possibilities or something. So it'll be quite large relative to the number of steps, but still the whole thing might be finite. Even if it turned out like that, and even if there are creatures who figured it all out and know that everything is finite, I think that they would still have use for the concept of infinity, because they would still be able to imagine that things had gone differently. Even if the world is digital, you can imagine a continuous universe. It doesn't seem that there's anything that somehow or other it's going to turn out to be something that you can just work out a priori, or something that's just obvious that the universe is digital. And so you'll still be able to make sense of these ideas about the infinite, even if it turns out that they don't actually apply to reality. So I'm not sure that I think that there's going to be any way of sort of pinning it on some kind of confusion on our part that we've got the concept of the infinite. It doesn't seem unreasonable for people in the past to have thought maybe the past is infinite, right? And that's not something that we're now inclined to think, because we've got 20th century physics and chemistry and geography and biology and so on behind us. And so we think that, at least for the observable universe, that is, the past is finite. But if you wind the clock back a couple of thousand years, when people hadn't made all of the detailed observations of geological ages and things like that, it may not have been so unreasonable for them to think, well, maybe things are as they are because they've always been this way. The past's infinite. We just, the present's just a kind of copy of what came before. So I'd be reluctant to think that it's ever going to be that we'll decide that the interest in the infinite was kind of irrational.
Graham, I wanted to pick up on your talk just a moment ago about the infinite, and as you were speaking, it was occurring to me that there are some things that can be infinite or seem infinite that really are finite. Obviously, a circle or a sphere, in that I could potentially, if there were no oceans, I could bike or drive a car and keep going around the Earth forever and ever and ever and ever. But clearly, the Earth is not finite. Certainly, its surface is not infinite, rather. And in the same way, I was thinking about the old Nietzschean notion of eternal recurrence, and people would say that, well, in an infinite amount of years, everything will play out as it has before, and another Graham and another Dan will be conversing on another kind of Skype, and this will occur infinitely amount of times in the future. But to me, that seems a sort of an absurd thing. Um, uh, First, let me address the idea of something that could be seemingly infinite, like a sphere or a circle, but not really infinite. Um, is there any kind of paradox inherent in that?
So I don't think so. I mean, in the case of the sphere itself is finite, but the number of um,
Circuits, around it.
the number, yeah, I'm just trying to think of the word because there's a technical term for it, but anyway, it
Yeah.
doesn't matter. The number of circuits that you can make, Aristotle would be happy to say, well, that's potentially infinite. If you go on living and you go on walking, let's suppose it takes you a year to do a circuit, then in 100 years you'll do 100 circuits, in 1,000 years you'll do 1,000 circuits, and so on. That number just goes on going up and up. So while there's nothing about the sphere itself that's infinite, there's certainly the possibility, it seems, of infinite traversal. I mean, someone who knows a bit more physics might worry that eventually you're going to wear the sphere away,
Yeah.
and you won't be able to go on circling forever. But yeah, I mean, it doesn't seem that there's anything particularly problematic there, but it also doesn't seem that there's anything that threatens the thought that the sphere is just a finite thing.
Uh, Now, getting to the idea of eternal occurrence brought me back, though, to thinking about what you earlier had been talking about, with that there being different sets of the infinite, i.e., that uh, let's assume that it's true that there'll be an infinite number of Grahams and Dan infinitely Skyping in infinite stretches of time forever outward. But it would seem to me that before we even got to the second Graham and the second Dan, assuming we're the first doing that, that there would be an infinite number of possible other events, an infinite number of possible other beings that would have to occur before even the second Dan and the second Graham had this conversation. So it would seem to me that there's a perfect real world example, if eternal occurrence or something like it is true, of what we were earlier talking about, does it not?
So there's various things to say here. I think that the Stoics actually had the idea that there's only a finite number of possibilities in an infinite space, and so if you went far enough away from here in a given direction, eventually you'd strike another Graham and Dan having this conversation. So on the question about eternal return, the thing that you said second seems right to me. There's no reason to suppose that just that if the future's infinite, at some point there will be a recurrence. There'll be another Graham and another Dan, and they will be having a conversation that's exactly like this one. I don't think that it's right to suppose that even if the universe is infinite in time and space, that all possibilities will be realized somewhere in it. The reason why I think this is because there's a kind of path dependence. What you can get to next depends upon where you are now. And it may well be that the future of the universe is one where life disappears, the universe goes on expanding, the universe gets colder, right? There's an infinite future, space gets infinitely large, but almost no interesting possibilities are realized after all the protons decay in about 10 to the 40 years. So I think that you can't get just out of infinite space and time, you certainly can't get something like eternal recurrence. Can I say one other thing, which
Sure.
is that Nietzsche didn't think of this as a kind of interesting metaphysical speculation, in my view. What he was interested in was the idea that there was something very affirming about saying, I accept my life even if I think that it's going to happen infinitely many times over and over again. So I'm going to have all these headaches and all this suffering over and over again. But nonetheless, I embrace that. I think that that will be wonderful, or something like that. I think of that for Nietzsche, the eternal recurrence it's more like an ethical claim than a metaphysical one.
You said ethical in what sense?
Well, in the sense that I just tried to articulate, he's saying something about the value of his life,
Okay.
and the value of human life, rather than engaging in some kind of metaphysical sort of speculation about what the large scale structure of space and time might be.
Let me turn our gaze forward rather than looking backward, because we've talked a bit about historical concepts and sort of, I guess, just philosophical, abstract aspects of infinity. But, we are living in a world now where we may, within a couple of decades, be on the cusp of artificial intelligence. Maybe by the end of this century, we may be taking our first steps in terms of putting colonies on the moon and Mars, and assuming that there aren't aliens that are out there that are going to eat us or wipe us out or enslave us or something. Our future seems to be out there in what may be infinite space. So let's talk about the future of the infinite, at least in the human conception of it. What do you think are some practical applications of infinity as the human race goes beyond the mere earth-bound status it has now?
So I guess I think that even if we were to, say, first step, colonize some nearby star systems, and then move on to colonize the Milky Way, and then to move on and colonize some other galaxies, we would never lose sight of the fact that our domain was finite. It's just a lot bigger than the Earth. So I also think that, though this is a kind of separate question, that it's pretty unlikely that we will be able to do very much of this colonising program. And I've read a certain amount of stuff by people like Freeman Dyson, Frank Tipler, and other people who are more sanguine than I am. But their views typically are that we will send little self-replicating machines out that will seed planets, that will give rise to life eventually. And if we sort of send them with the right instructions about DNA, maybe they'll produce something like people. But there's so many uncertainties in that kind of speculation. I do think that it's pretty fanciful at this stage.
Do you think that, because you mentioned what amounts to the idea of the infinitesimal as the infinitely small, do you think that perhaps that the infinite may be found in a sense in the infinitely small? And since you mentioned Tipler, he's famous for what is it called, the omega point, and the idea that a civilization as the universe would maybe come back in as a big crunch might develop some technology that makes an infinitely seemingly small amount of time infinite in terms of perception, and therefore we could upload ourselves or whatever into an infinite future. So is the infinitesimal more reachable than the infinite, perhaps?
So I think one of the big problems for Tipler's view is that subsequent investigation showed that the universe doesn't have the structure that it would need for there to be the kind of big crunch that he's got in mind. So his particular view, I don't think, is going to help here. On the question, though, about the infinitesimal, I think just as there are limits to how far we can probe, so it will all, what we can observe may get a bit bigger, though it's kind of limited by the speed of light, really, what the size of the observable universe is at any point. It may be that there'll always be limits that frustrate our ability to find out about the very small structure as well. So if you think about, and those could be of various kinds. At the moment, our view about quarks is that they're bound, so you can never observe a single unbound quark.
Mm-hmm.
It may be very difficult to find out anything to probe the internal structure of quarks, and that just might make a limit. The size of quarks at the energy level that we're talking about is way above the Planck limit. So some people hypothesize that there's this limit at about 10 to the minus 40
Planck length
meters or something, Planck length. Right. Well, quarks are nowhere near that. So there's a vast number of order of magnitudes that of potential structure that we may never be able to probe.
Well, I believe that in terms of orders of powers of 10, that we are considered extremely large in the cosmic sense, because I think there's something like 8 to 10 orders of powers of 10 smaller that we can observe than large scale structures, something like that.
Yeah, I think that's right. So, but I'm not sure that there's really going to be any kind of asymmetry here between our sort of attitudes to the very large and our attitudes to the very small, and our abilities to probe the very large and the very small in connection with the universe. I suspect, maybe this sounds a bit pessimistic, but I suspect it will be sort of equally limited in both respects.
Well, since infinity also refers to the idea of the ineffable, the divine, and we started off at that point, what do you think of the future of the study of infinity in this sort of, I guess, metaphysical sense? And I'm not talking about, future beliefs in God or other new gods or religions that may or may not arise, but is there any practical application to using a term or the ideas of the infinite in the sense of what we were talking about earlier, non-Cantorianly?
So I'm inclined to think that we should use the Cantorian ideas wherever we can. And it turns out, in connection with some, I'll call them theological uses of talk about infinity, that actually we can interpret that in Cantorian terms. So I gave an example before, sort of being infinitely knowing might be a matter of knowing some fairly large infinity of propositions, knowing that they're true, something like that. So it might turn out that some of the theological talk is reducible, and then what I suspect is that the rest of it will turn out to be interpretable in other terms, right? So it might just be that, for example, you want to say that God or your divine or whatever is maximal in a certain respect, but maximality doesn't necessarily mean infinity, right? I get the maximum possible score on a test out of 100 and I just get 100. I don't get infinity. So when you're talking about the things that in some sense have no, hitting a maximum doesn't commit you in any sense to an infinity.
I want to ask a final question regarding infinity, and then I just want to wrap up the interview asking a couple of questions about your own personal explorations into the infinite. As regards infinity, either in the mathematical or the metaphysical sense that we've been speaking of, is the idea of infinity, do you think, falsifiable, i.e., is infinity in any sense scientific?
Right. So I think that investigations of the infinite can be you can certainly do mathematical investigations as Cantor does, and I'm prepared to call them scientific. You can do philosophical investigations of the kind that I did in my book, Philosophical Perspectives on Infinity, and I don't think of that as science. I think that there's a distinction between philosophy and science, so it'll be a bit of a detour to talk about that. I certainly think that there are applications of the concept of infinity all over the place in science. So there are part of what happens in science is that you make models and you make certain kinds of approximations, and then you get out results that are pretty good. And so often in scientific modeling, you allow certain parameters or things to be infinite, and then you discover that you've got a pretty good model for actual phenomena. You know that this is just an approximation. So to give one kind of example, it might be that really to give an exact account of certain phenomena, you might use difference equations, which are finite, rather than differential equations, which are continuous. But the differential equations turn out to be much more mathematically tractable than the difference equations. So you couch your model in terms of differential equations, you get out results, and you get really good fit with empirical data. You might have got a better fit if you use difference equations, but actually you just can't process the mathematics for them, and so you can't do that. You can think of the infinite modeling as giving you an approximation to what turns out to be a non-infinite reality. That would be a possibility, right? So science can use infinity all over the place. What the consequences of that are unclear, right? Whether we should think from that, okay, so there really is infinity in the phenomena or not, that's going to be an open question in every case.
Well, let me ask then about your own finite future. You said that you've written on infinity before. Will you ever be tackling the subject again? And if so, or if not, what is your next book or next paper going to be on?
Okay, so I suspect that because I'm still interested in things like Pascal's wager and cosmological arguments, I'm never going to stop thinking about infinity altogether. But I do have other interests in sort of more general questions about what makes for a good argument, what are the prospects of making sort of convincing arguments that would get people to change their mind on the question about the existence of God, and so on. And my plan is to write a book about those kinds of questions. And if I do that, then if that's the next thing that I do, then I probably won't be thinking much about the infinite in the short-term future. But as I said, in the longer term, I plan to write more about Pascal's wager, teleological arguments, cosmological arguments, and it's hard to write on any of those topics without occasionally having to say something about questions about infinity.
I guess the only one question that I would pluck out from there is, since I had mentioned the tie between the infinite and the concept of God, if there was ever a way to prove that the cosmos was not infinite, that time was not infinite, would that also concomitantly be disproof of the existence of at least a monotheistic God, as the Judeo-Christian tradition has it?
Well, it's interesting that you ask the question that way, because there's one of the currently popular arguments for the existence of God is the Kalam cosmological argument, and one of the ways of supporting the claim that the past is finite, which is an essential part of that argument, is to argue that there can't be, it's impossible for there to be any actual infinities. So you might, if it turned out that you could prove that the world was finite in all respects, then in particular you'd have shown that it was finite in the past, and some people at least would think that rather than disproving the existence of God, that contributed towards proving the existence of God. Yeah.
That's an interesting thing. Well, anyway, I want to thank you for spending about an hour speaking with me. I will link to your page as it is pronounced Monash or Monash?
Monash.
Monash University in Australia. So thank you, Graham Oppy.